The problem that we are going to discuss today is charges. The problem appeared in May 21 lunchtime and has a difficulty level of simple. There are no prerequisites to solve this problem. The problem statement goes as follows. We are given n subatomic particles lined in a row, and the particles can be represented by 1 and 0. That is, positive charges are represented by 1 and negative charges are represented by 0. It is also given that like particles repel each other. Therefore, they are 2 units apart, and if the consecutive particles are of different charge, then they are separated by 1 unit. So this information is given to us. Now, what is the question? The question asks that we will be given the n particles in the row, that is the initial arrangement, and after that we have to change some particles charge k times. That is, in the ith update, a particular charge of the qith particle will be flipped. That is, if it is 1, it will become 0 and vice versa. Also, after each update, we have to find what is the total distance between the first and the last particle. So k times we have to report the distance between the first and the last particles. And remember, the changes that we are making or the updates are persistent. That is, the change made in the first move will be persistent for the second move, similarly for the third move, and so on. So let's understand this better using an example. So I have here a total of 5 charges, as you can see, 1, 0, 0, 1, 0. So initial arrangement is this. So let's find out what is the distance between the first and the last particle initially. So I am taking some referral point. So let's say the reference point is x is equals to 0. So this particle is present at 0. Because these two particles are of opposite charges, they will be 1 unit apart. Then because they are of same charge, they will be 2 units apart. Again, they are of different charge, so 1 unit apart and 1 unit apart. So you can see that the first particle and the last particle are total 5 units apart. So let's say we make a change. So the change is that change the third particle's charge. So what will happen is that this particle will now become of the other type, that is, it will change from 0 to 1. Now again we have to report the distance between first charge and last charge. So if you calculate, the answer will again come out to be 5 units. By taking some reference point like x is equals to 0, if you again calculate all these uh, distances, then the distance between first and last particle will again come out to be 5 units. So here we have made just one change. Like this, in the question there will be given total k changes that we have to make, and after each update we have to report the distance. So this was the question. Now let's see how to approach the solution. The solution approach goes as follows. First of all, we have to calculate the initial distance between the first and the last particle. So I have an example drawn over here, and let's say the distance between the first and the last particle initially is stored in the variable called as len, len. Okay, now for the k subsequent changes that we are going to make to the charges, we only calculate the change it is bringing in this length. So for example, the input says that I have to flip the fourth charge. So I will come over here and change the fourth charge from 1 to 0. But notice that after making this change, the configuration of charges 5 to 8 remains the same, and hence the distance between the consecutive charges from charge number 5 to 8 is what it was initially. It hasn't changed. Same is the case for charge 1 to 3. The only change that is going to happen is between charge number 3 and 4 and charge number 4 and 5. So the point where we are making the change is happening only in its vicinity. Rest all configuration remains same. So we'll only calculate the change that this charge number 4 is bringing. Let's call that change as delta. So what will be my new length? My new length will be len is equals to len plus delta. Now this delta can be either positive number or negative number, or it can even be 0. that is the length can remain same. So each time we update our length, and each new time we are told to make a change, we just calculate this delta and accordingly add it to our length to get the new length. And then we keep on reporting the same as our answer. So this is the basic idea of the solution. Now let's see that how to calculate this change at each step. So to calculate the change in each step, we need to only look at the particle to the left and particle to the right. So let's say my earlier the particle was 1 and to the left the particle was 0 and on the right as well the particle was 0. So this is the earlier configuration. Now if I am told to change this charge, so I am going to flip it. So now this charge will become 0. So this charge will become 0 and the left and right charges will remain the same. So what I have to check is what is the configuration now. So now you can see that towards the left the configuration is same, that is 0 and 0. It means that now they will be 2 units apart. Same is the case for right hand side, 0 and 0, that is they will be 2 units apart. And observe one thing, if right now the configuration is of the same charge, then definitely earlier the configuration should have been of opposite charge because we are flipping the charge, right? So if right now the configuration is of the same charge, then earlier it will be opposite. So what is the change that we brought here? Earlier they were 1 unit apart, now they are 2 units apart. Same is the case for right hand side. So the change that we have brought is plus 2, because earlier this whole was 2 units, now this whole is 4 units, and the things to the left and things to the right remain unchanged, right? Because they are not affected by our current change. So overall we brought a change of plus 2 in our answer. So this was one example. Similarly, you can check for other cases as well. The summary of what you will get is as follows. Basically, when you make a change to a charge, so let's say this is some charge Q, this is the charge to the left, and this is the charge to the right. So after making the change, whatever is the configuration between L and Q dash, if they are of the same type, then your len will become len plus plus. If they are of opposite type, then your length will decrease by 1. Same is the condition for the right hand side. If after making the change, the charge and the charge to the right are of same configuration, then again your length will increase by 1. And if they are of the opposite charge, then your length will decrease by 1. And why this is happening is because when you make a change to the charge, like Q becomes Q dash, they are flipped, definitely the configuration changes. That is, if earlier they were not matching, now they will match, and vice versa. If they were matching earlier, now they will not match. Why? Because we are flipping the charge, right? So the configuration is going to exactly become opposite. So that's it. The changes will be like follows. Increase by 1 or decrease, and check on the right hand side. Again it will either increase or the length will decrease. So the change happens only locally. That is, wherever you are making the change, only the left and the right charge will decide what the answer will be, not the other remaining charges. Hence, we took this approach. I hope you guys have understood the approach. It will be more clear when we see the code. So the implementation is as follows. For each test case, we take the input for n and k and then the string. Then first we calculate the initial length or the initial distance between the first charge and the last charge. How, how is that done? First, of course, the answer is going to be minimum n minus 1 because there are total n charges, right? So I'm just placing them one beside another. So in that case, the answer will be n minus 1. And then I calculate how many consecutive charges are of same type. If they are of the same type, I increment my answer by 1. So all the consecutive charges are checked and similarly my length is increased. So this is my initial length. Now for k times I have to take the query from the input. So I take the query q and I do q minus minus because the indexing that I am following is zero based. Now I make the change. What is the change? If the charge at index q is 1, I make it 0, or else I make it 1. That is, I flip the charge. Now after flipping the charge, I check if there exists any element or the any charge to the right hand side. Then I check if right now the configuration is of the same type. It means that earlier it wasn't of the same type. So I increase my length, and in the else case I decrement my length by 1. Similarly, I check if there exists a charge on the left hand side, and right now if the configuration is same, that is the charges are of same type, positive positive or negative negative, then I increase my length by 1, or else I decrease my length by 1. So our solution works in the following manner. Now it will be better understood if you take an example and write it on a paper. It's very hard to do it right now because the example can be quite long, because you have to take a reference point like x is equals to 0 and then calculate all the lengths again. So it's better that you try it by your own. I hope you guys have understood the solution. And finally, after each of these calculations is done, every time we output the resultant length, that because that is asked in the question. So that's it, that completes our solution. Now I would like to tell you guys about the competitive programming tutorials that we have at CodeChef. So if you are facing difficulty in any CP topics, you can come over here and look at these free lectures taken by our educators. And if you want even more structured content, you can opt for the plus subscription on Unacademy, where you can use my referral code Darshan 25 to get instant 10% discount.